Hello students, today's lesson is about addition and subtraction of fractions with different denominator. Let's start first with addition of fractions with different denominator. In this figure, I have two units. Each unit is a circle. These two units have the same size. The first unit is divided into 3 equal pieces and the second one into 6 equal pieces. Let's add them. The green piece represents the fraction 1 over 3 and the blue pieces represent the fraction 4 over 6. Let's add these two fractions. Do you think that to add these two fractions we need to add the numerators and denominators? Let's see. Do we do 1 plus 4 over 3 plus 6 equals 9 equals 5 over 9? No, this is completely wrong. Why? Attention, I cannot add fractions if they don't have the same denominator because the size of the pieces is not equal. Here, the pieces and the fraction 1 over 3 are bigger than the pieces and the fraction 4 over 6. If we extend the parts, we will notice in fact that each piece and the fraction 1 over 3 is double the size of each piece and the fraction 4 over 6. The green piece is double the size of the blue piece. So let's see how we should add these two fractions. First, we notice that 1 over 3 is equal to 2 over 6. So we replace the fraction 1 over 3 by the fraction 2 over 6. And we copy plus 4 over 6. Now we have same denominator. So we add both numerators and we copy the denominator. It's equal to 6 over 6, which is equal to 1 because the numerator and denominator are the same. And we box the answer. In fact, the fraction 2 over 6 is equal to the fraction 1 over 3 because if you multiply the numerator and denominator both by the same number 2, we obtain the fraction 2 over 6. Here, because each green piece is double the size of the blue piece. Rule: to add two fractions, they need to have the same denominator. If they don't, we cannot add them. The same denominator is a multiple of both denominators. Here 6 is a multiple of 6 of itself and a multiple of 3 at the same time. I cannot add fractions if they have same numerator but different denominator. For example, here if I have the numerator 2 and 2 but different denominator, I still can't add both fractions. They need to have only same denominator. Now, how do we find the same denominator? The same denominator is a common multiple of both denominators. Let's do this example to understand this concept more. Let's add the fractions 2 over 3 plus 3 over 4. First step, we write over plus over equals over. This is the first thing that we need to do. Now let's see the general method and the steps that we need to follow. To find the common multiple of both denominators, first we write few multiples of 3 of the first denominator. I wrote the first 5 multiples of 3, 3, 6, 9, 12, 15, and it goes on. Then I write few multiples of 4. I wrote the first 3 multiples of 4, 4, 8, 12. I find the smallest or least common multiple of 3 and 4 other than 0. If you noticed here, I didn't write 0 in the list of multiples of 3 and 4. First, because 0 is multiple of all numbers, And second, because the denominator cannot be 0, because anything over 0 is impossible. So here, if you look at the list of multiples, we notice that 12 is the least common multiple other than 0. So it's the common or the same denominator. So we write 12, 12, 12. Now, step number 4, I find two equal fractions with the same denominator, then I add them. Now we are going to find a fraction equal to the first fraction 2 over 3 and a second fraction that is equal to the fraction 3 over 4 with the same denominator 12. All I need to do now is to find the numerator of these two fractions. Attention, to find equal fractions, I multiply both numerator and denominator by the same number. So to find this fraction equal to 2 over 3, whose denominator is 12, I ask myself 3 times what equals 12? It's 4. So I multiply both denominator and numerator by the same number 4. I do 2 times 4 and I write the answer here. 2 times 4 equals 8. So 8 over 12 is a fraction that is equal to 2 over 3, whose denominator is 12. Now I do the same for 3 over 4. I ask myself 4 times what equals 12? It's 4 times 3. I do the same for the numerator. I multiply 3 by 3 and the answer is 9. Now we have two fractions, two equal fractions with the same denominator. Now I add them. I do 8 plus 9 and the answer is 17 over 12. And this fraction cannot be simplified. I box the final answer. Now practice. Let's add these two fractions, 5 over 6 plus 3 over 8. First, I write over plus over equals over. This is the first step always. Remark, in order not to waste time listing the multiples of both denominators, I list in my head the multiples of the bigger denominator until I find a multiple of the smaller denominator at the same time. Here, in order not to waste my time and write the multiples of 6, then the multiples of 8, I see which denominator is the biggest here, which one is the greatest. It's 8. I start listing or counting in my head the multiples of 8. So in my head, I start listing the multiples of 8 until I find a multiple of the smaller denominator here, 6. Let's start with the first multiple of 8 other than 0, 8. 8 is a multiple of itself, but it's not a multiple of 6. So no, it cannot be the same denominator. After 8, we have 16 as multiple of 8. 16 is also not a multiple of 8, so I cross it. After 16, I have 24. 24 is a multiple of 6 because 6 times 4 equals 24. So I found my denominator. So it's 24. So I write 24, 24, 24. Then I need to find the numerator. So I ask myself 6 times what equals 24? It's times 4. I multiply the numerator also by 4. 5 times 4 equals 20. 8 times what equals 24? It's times 3. I do the same for the numerator. 3 times 3 equals 9. Then I add both numerators because I have now the same denominator. And the answer is 29 over 24. This fraction cannot be simplified, so I box this final answer. Now another example, 7 over 6 plus 5 over 9. So first step I write over plus over equals over. Now 9 is the bigger denominator. So in my head, I start listing the multiples of 9. 9 is a multiple of itself, but it's not a multiple of 6. After 9, I have 18. 18 is a multiple of itself and of 6. So I found the same denominator. So I write 18, 18, 18. Now I ask myself, 6 times what equals 18? It's times 3. I do the same for the numerator. I multiply it by 3. 7 times 3 equals 21. Now, 9 times what equals 18? 9 times 2 equals 18. I do the same for 5. 5 times 2 equals 10. Now I have two fractions with the same denominator, 18. I add both numerators, 21 plus 10 equals 31 over 18. This fraction cannot be simplified anymore, so I box the answer.